Hi and welcome to this quick review on volume, capacity and surface area in preparation for your classes where you'll learn this in a lot more depth. So this should be the simple stuff. Let's talk about some different 3D shapes that you might want to calculate volumes for. We're going to start here with our favourite 3D shape, prisms. Prisms are a grouping of shapes that have a certain particular property. And I've got here 3 examples of prisms, and they're all sat up on their base or on their front face. So these could be rotated around. You could be looking from this side here, for example. This could be the front eye. This could be your eye here, looking at these prisms, and it might look a little bit differently. But the important thing about a prism is it's a 3D shape, and it has this front face. Put in a good colour. Here we go. This front face in light blue is the same as the back face down here, and actually the same as every other cut through the middle. So you'll see that this is exactly the same size triangle. So a prism is a special shape that has a front face that is repeated throughout. The shape is built on that front face being moved throughout. And if I cut through here, I'll get the same shape again and again and again. This is called a triangular prism. This one is called a rectangular prism. And this one here is called a pentagonal prism. And possibly the best one to actually look to visualize what a prism is, because I can see the pentagons that come out. If I do cut this continually, I'll get more pentagons inside the prism. Now the volume of a prism is equal to the area of the base times by the height. Now the height may not be the height if you're looking at the prism lying on this purple side here, for example. Then the height might also be called the depth or maybe the length. So just be careful of that. But all you need to do is find that common front face here, find the area of that, and then multiply it by how deep or how high it is. And you'll get your volume. It's that simple. If you're lucky, we're looking at a triangle or a rectangle, and finding the area of the front face is pretty easy. Maybe if you're unlucky, you've got something here like a pentagon, which is actually quite tricky, but can often be broken down, or maybe you're given the area of the pentagon or there's some other hint in the question. So there you have it. That's how you find volumes of prisms. Now we may also have to find more complex prisms, and this is a pentagonal prism as we're just talking about, and it looks pretty difficult, but you'll see here that this front face is common. I've just drawn all over our dimensions because it's the same as this back face, and every face in the middle, if we slice this prism that's lying down, you'll get that. And we have a 14 metre depth. So if I rub this out now, hopefully you can see that actually the front face, whilst looking complex, is really just made up of a top part triangle and a bottom part trapezium. And you've done those two formulas in your area work. So this is quite easy once you break it down into those pieces. So I'll be calculating the area of the triangle, area 1, the area of the trapezium, area 2, adding those together, multiplying by the depth of my shape, 14, and you've got your volume. Even complex shapes can be solved pretty easily, but you'll see some of those in class. Now, we also have these shapes. This is a pyramid, which you will have seen before, and you'll need to know how to find the volume of a pyramid. Now, here's something special that I'll show you, and we'll do some more depth in class. That's the base shape. So I'm not pointing at the side here, I'm pointing at that shape underneath. In this case, it looks like a square. Now let's call the area of the base A. And this is the altitude. That's one name for it, because it's a very common name, and we'll call that the height. It's the perpendicular height, because it creates a perpendicular with the base. Whereas we've also got, and sometimes this is handy, a slant height, but that's the diagonal height. And that's not useful in this case for finding the volume of a pyramid. And it turns out the volume of this pyramid is a little bit like the volume of the prism. Area times height, except it's just a third of that. That's right. The volume of a pyramid is a third of the prism that it's contained within. And we'll explore this a little bit more in class. The slant height can be quite handy when it comes to particularly some work with cones that we'll do later on. And of course, hopefully remember a cone is just a pyramid with a circular base. Now we'll talk about spheres in class as well. They have a really just a base level formula that they'll be using, and so there's no big problem there. And here is the formula sheet. And as you can see, all the formulas that you need are contained on this formula sheet. So make sure that you are used to where they are and you're happy to refer to it. Now let's talk quickly about the difference between volume and capacity. And I'm going to do this verbally. So the volume of a shape is the amount of space that's occupied within that shape, how much space it covers. And volume's always measured in a length cubed, so millimeters cubed, or maybe centimeters cubed, or maybe meters cubed, or whatever, kilometers cubed, whatever it is. It's a length cubed. On the other hand, the capacity of the shape is the amount of probably liquid that it can hold. Now, of course, a shape can hold a solid or a gas as well, but when we're measuring shapes, we often think of it as a liquid, and that's usually where we fall back to. And so the capacity of a shape is in milliliters, or maybe liters, or maybe even kiloliters, which you haven't seen before, or maybe you have. And there's an important link here because capacity and volume are quite similar. And it actually turns out the most basic length is this one. That's right. 1 centimetre cubed is equal to 1 milliliter. Now I'm sure somewhere near you, you have a 500 milliliter bottle, or maybe a litre bottle. A 500 milliliter bottle could hold 500 centimetre cubes. Go back to your time in primary looking at those little wooden centimetre cubes. 500 of them would fit in there, and believe it or not, it's true. It's just they're not really the right shape, so it doesn't fit in usually that well, but the point is still there. So that's a capacity volume discussion, an important piece of language, and you need to make sure that if you're asked for the capacity, that you answer in a unit that is appropriate for capacity. Whereas if you're asked for volume, again, you answer in the appropriate unit. Okay, lastly, we're going to talk quickly about surface area. So I'm not going to spend a lot of time on surface area. I am going to remind you, though, that you have done a lot of work in the past on area. So if you get a surface area question, any surface area question, excepting maybe some of the ones that seem a little bit more complex, like a sphere, and actually a sphere's surface area is pretty easy. Again, refer to the formula sheet. This question here looks really tough. It's got a trapezoidal front, a trapezoidal back, and 4 sides. If I needed to find the surface area here, I would have to find the area of this face, this face, this face that's around the side there, this face that's underneath, this face that's on the front, and this face that's on the back. But you know what? I've done area before. The area of 5 and 6, because as a prism is the same, and the rest of them are just rectangles. So I've got to find the area of 1 trapezium and 4 rectangles and then add it all together. Surface area questions are big. They're considered complex, but they're considered complex familiar in most cases. There's a lot to the process, but it's all stuff you've done before. So you don't need to be too worried about surface area. It does help, though, if you do a fair bit of practice on them. So I'm going to leave it there. It's a bit of a run-in on volume, capacity, and surface area. Hopefully it helps. And as you go into class, remember the simple stuff, and you'll be fine with the complex stuff, and you can ask the questions because we'll have plenty of time in class. All the best.